Welcome to today's Explainer. Look, if you're building modern web apps right now, you've absolutely heard the massive buzzwords circulating out there. Decentralized architecture, zero trust environments, Web4. We hear them all the time. But there's always been this incredibly frustrating, massive gap between reading about these theoretical concepts and actually figuring out how to deploy them in your code. Well, today, we are officially crossing that bridge. We're going to take a deep look at the Linkspreed UIID API V1 Cookbook, which just dropped a major update that transforms it from a concept into a production-ready, hands-on integration toolkit.
Okay, let's dive into this. Here is our architectural blueprint for today's deep dive. First up, we'll cover the passwordless identity layer. Then, we'll be unpacking sovereign identity primitives. Third is 5 languages, 1 workflow. Fourth, we'll look at complete API endpoint coverage. And finally, we'll wrap up with secure offline testing tools.
All right, let's jump right into Section 1, the passwordless identity layer.
I want to speak directly to the developers and systems architects out there for a second. We all know that building zero-trust infrastructure from scratch has historically been, frankly, a massive headache. You're dealing with managing credentials, securing databases, preventing data breaches, all while trying to patch together various privacy frameworks that usually just conflict with one another. Which brings us to this really fundamental dilemma. How do you authorize a user without holding a password and without tracking them across the web? It sounds like a total paradox, doesn't it? Because normally recognizing a user literally means tracking them. But solving this exact dilemma is precisely what the UIID Cookbook is designed to do for modern development teams. It gives you a standardized, rock-solid layer to recognize your users securely without ever compromising their privacy during the transaction.
Moving right along to Section 2, Unpacking Sovereign Identity Primitives.
So, before we even think about writing a single line of integration code, before we ever spin up a server, we absolutely must unpack the conceptual what behind sovereign identity. We really need to understand the basic building blocks of this new architecture. The absolute most important building block here is the core ID. This is the permanent, cryptographically unique anchor of a user's digital existence. It's formatted as a decentralized identifier, so it looks something like did UID followed by a unique hash, like 91B 3239 521D 8399. To really grasp this, think of a spatial analogy. Imagine the web as this vast, turbulent, and constantly shifting ocean. Your core ID, it's that heavy, permanent anchor dropped securely and firmly into the seabed. It is the absolute source of truth for a user in the UIID ecosystem. It doesn't move, and it doesn't change.
But here's the catch. An anchor all by itself doesn't actually give you privacy. In fact, if you use a single identifier everywhere, that's exactly how you get tracked. That's where aliases step in, and this brilliantly illustrates the contrast. On one side, you have your core IDs, those permanent, cryptographically unique anchors we were just talking about. But on the other side, you have aliases. These are your disposable, contextual, isolated masks. Structurally, these sub-identities are isolated per application context. Let me really emphasize those words: disposable, contextual, isolated masks. This means an app can totally, confidently recognize a user within its own specific boundaries, but they physically cannot track that user across different apps in the wider ecosystem. The entire architecture fundamentally blocks cross-app tracking, because the alias you use in app A shares literally zero mathematical link to the alias you use in app B.
Next up, we have immutable nodes. Think of these as non-editable data anchors that require explicit, user-initiated deletion requests. By just setting a very simple flag in your code, setting is_immutable to true, you effectively lock that key value pair directly onto the identity structure itself. So why does this matter so much? Because it takes the power of data modification and places it firmly back in the user's hands. Any removal or change happens by design, physically requiring the user to explicitly request and sign off on it. Absolutely no back-end admin can casually overwrite an immutable node. That completely shifts the traditional trust model.
And to complete the sovereign identity puzzle, we have a couple more really clever primitives. We have shared buckets, which give you real-time collaborative access control between different UIID identities, and it does this all inside the exact same alias context. You can think of it like building a highly secure multiplayer environment without ever leaking the underlying user identities. Pretty cool, right? Then we have smart tags. These enable silent cross-site identity detection using super secure HTTP-only cookies. And because they use HTTP-only cookies, they are completely invisible to client-side scripts, completely protecting your users from cross-site scripting attacks. When you put all these pieces together, they give your apps full functionality, awesome collaboration and super smooth user experiences without ever deteriorating into those creepy tracking vectors.
All right, let's step into Section 3. 5 languages, 1 workflow.
So we've officially crossed the conceptual bridge of understanding the architecture. Now let's focus on the actual how. This repo update isn't just theory anymore. It gives you a highly practical, concrete integration kit tailor-made for cross-platform deployment. Now, what's really interesting here is the strict parity across all 5 tracks. You've got comprehensive tracks for JavaScript and Node, Python, PHP, Go, and even raw curl and shell scripts. Each one comes with its specific requirements and included SDKs or test runners. But whether you're using Jest for JavaScript, PyTest for Python, PHP Unit, or Go's native testing environment, the overall structure is identical. The example files are named the same, and the workflow numbering matches up perfectly across the board. The learning curve is basically flattened completely no matter what tech stack your team happens to be running.
In fact, it gets even better. Every single track starts from the exact same entry point, 01_auth_OIDC. This represents a deliberate, massive friction reduction in the developer experience. A Python backend team and a Go microservices team are literally sharing the exact same starting line. You just install your specific language dependencies, run the universal test command, and boom, you are immediately walking through app management and core ID operations in perfect sync.
Which brings us to Section 4, Complete API Endpoint Coverage.
This is arguably the biggest headline feature of the Linkspreed update. Every single module of the V1 specification is now completely implemented. Let's do a rapid-fire rundown of this toolbox so you can see the immense out-of-the-box power your team can leverage. First, you have OIDC and Auth for automated discovery and standardized ID tokens. You've got app management, so you can seamlessly onboard and immediately revoke credentials. The Core ID API is right there for querying dynamic trust scores and writing to encrypted key value storage. Then there's the incredibly deep alias network, which lets you programmatically spawn, lock, and permanently purge contextual identities. Shared buckets are fully mapped out for assigning collaborative access roles. And to top it all off, you get comprehensive auditing and webhooks securely signed by HMAC SHA-256 secrets. It is a remarkably robust, production-grade toolset covering absolutely every angle of identity management.
Finally, let's look at Section 5, Secure Offline Testing Tools. I want you to imagine for a second trying to test a fully decentralized, passwordless identity integration completely live. Think about the nightmare of coordinating all the webhooks, managing complex token refresh flows, and doing all of this while risking production servers or accidentally meddling with real user data structures. It would be a complete bottleneck, right? Well, this update solves that entire nightmare instantly with one single command, Docker Compose upbuild. Running this instantly orchestrates an Express-based UID mock server right alongside test runners for all 5 of the language tracks we mentioned, running entirely on your local machine. So teams can validate really complex refresh token flows and webhook signature handling entirely offline in a perfectly safe sandbox. Then, once everything passes, you just point that exact same code directly to the live endpoint. It's really that simple.
And through all of this, the cookbook isn't just leaving security in a footnote somewhere, it actually bakes in explicit security guidance. So the crucial point is that this framework proactively relies on 3 explicit security pillars. Number 1, verify every single webhook using your endpoint secret via HMAC SHA-256. This guarantees that the payload absolutely came from the UID network and wasn't messed with in transit. Number 2, assume short-lived tokens. UID bearer tokens forcefully expire in 3,600 seconds, so you are actually required to use secure refresh flows. This naturally minimizes the window of vulnerability if a token ever happens to get intercepted. And number 3, respect immutable nodes. Remember, data changes require user-initiated requests by design. The system literally won't let you bypass this. As the repository documentation so perfectly summarizes it, ultimately this update serves as a comprehensive bridge between theoretical identity-centric architecture and practical, cross-platform implementation. So developers, you now have the concrete tools readily available on GitHub to stop just theorizing about the future and start actively building Web4 applications today. Which leaves us with one final provocative thought to close out today's explainer. Are you ready to stop tracking your users and actually start empowering their sovereign identity? It really is a profound shift in how we handle data ownership and digital trust, moving away from centralized hoarding toward true decentralized empowerment. I highly invite you to dive into the cookbook, explore the UIID ecosystem further, and rethink what your identity layer can truly be. Thanks so much for joining me on this deep dive today, and we'll see you next time.